Hello student, the question says the stress strain graphs for material A and B are shown in figure 8.10 and they are given the graphs are drawn to the same scale. That means both are drawn using the same scale. Same scale means whatever one unit we have assumed for strain, we have assumed the same 1 unit distance for the other graph also. So they are drawn to same scale. Which of the materials has the greater Young's modulus? Which of the two is a stronger material? And when we say we have drawn to the same scale, that means you are telling that we can actually compare both of them and infer some points from both the graphs. The first question is which of the material has the greater Young's modulus? So we know Young's modulus is simply ratio of stress by strain. And this we generally define it within elastic limit. So ratio of stress by strain within elastic limit. And how do you get the ratio of y-axis by x-axis? In a graph, the ratio of y-axis by x-axis is nothing but slope of graph. Slope means how much it is at an angle with the x-axis or how vertical a body is looking. So if you look at both the graphs, this would be the elastic limit where stress is appearing to be proportional to strain, and here till here stress is appearing proportional to the strain. So this is a straight line we got. So this is one line that we have, and we have another line in this way. If you look at both the lines, which is looking more vertical, like which is looking more like a perfectly closer to the straight line, you can see this one is looking more closer to the vertical than this one. Or we can tell the angle here, if I call this as theta 1 and this call this as theta 2, so we can clearly see theta 1 is greater than theta 2. Or we can say tan theta 1. Remember, slope is not theta 1, tan theta is called slope. Right now, I will not explain in detail what is slope, or else this video would be lengthy. Just remember tan theta 1 is slope, tan theta 1 is greater than tan theta 2. Since slope of the first one, it is more closer to the vertical line than this one. It is looking a little bit less closer. So we can say Young's modulus of the first one of YA is much greater than the Young's modulus of the B. The answer for the first one is, since A has more slope than B, we can tell that the Young's modulus of the first one is greater than the Young's modulus of the second one. Now let us answer the second question. He's asking which of the two is a stronger material. Now, what defines a strength of a material? So strength of a material is defined by its ability to handle stress. Ability to handle stress. So whichever can handle maximum stress, we can say that body is the strongest one. So if I draw it, like visually, it appears as though both are handling the same amount of maximum stress. But if you take a scale and if you draw it properly, you will notice that there is a slight gap in the way that they can handle that stress. Like they are not exactly matching. If you take the highest point of this one and you exactly match it here, so you will notice there is a slight gap. You can take a scale and place it on the textbook and check it. You will notice that the first material is at a slighter elevation than the second material because they are drawn to scale. So whichever can handle the largest stress. So the largest stress value for the first one is slightly higher than the largest stress value for the second one. It is slightly lower. So if I draw it, so the other one is a little bit lower. So this is the largest stress the second material can handle. Since the first material can handle more stress than the second material before breaking, so we can say A is stronger than B. So strength is defined by its ability to handle stress. So A can handle more stress than B. Visually, it is very hard to tell, but if you have a scale or something like that, we can just mark it. I think in a competitive examination, if this question is asked, he will clearly show you so that you can visually see it and tell. Hope you understood how I have solved. Thank you.